Welcome you all again to an awesome session of Otters FTP 2021. Now it's time for our second session, which is on the topic machine learning based on load balancing for web streaming of images service application. To enhance our idea on this topic, we have with us another dynamic speaker, Mr. Subrat Kumar Acharya, scientist and head of Proven Systems and Networks at National Remote Sensing Center, ISRO Hyderabad. He has also worked as research fellow at Aeronautical Development Agency, Bangalore. But it gives me immense pleasure to inform you that he has also been a part of our CBT family as lecturer in instrumentation and electronics engineering during 2003 and 4. Needless to say, he is a pride of our institution. Speaking of his education, he holds a PhD in ECE from IIT Roorkee, and he has done his MS in software systems from Birla Institutes of Technology and Science, Milan. I think I need not to say anymore. I'll directly request Mr. Acharya sir to address the gathering. Please, sir.
It's not working. Am I audible now?
Yes, sir, you're audible.
Please start. Yes. Okay. Good morning to all. Now my topic is basically this machine learning based load balancing. That is, what are the industry practices used? I'm going to highlight on that, and maybe I'll just start with my PPT, then we'll take it forward. Okay, I hope my PPT is visible now to all. Please confirm, sir. Is it visible, my PPT?
Yes, sir, it's visible.
Yeah, okay. So thank you once again. So I'm going to present about this machine learning based load balancing for web streaming of image services applications. So currently my name is Subrat Kumar Acharya, and I'm working as a scientist here in ISRO, and I'm currently responsible for the systems and networks for the Bhuvan web portal. So on that also I will take you forward, like what are the new technology we are using in terms of current load balancing mechanism, and what are the new developments we are doing. And on that, maybe our previous speakers already highlighted mostly all this theory or security aspects and this private and machine learning algorithms. So those are the topics whatever is already focused, but here I am going to say that all these algorithms whatever we are using for AI or ML is all data driven. So here I have to focus mostly on the activities of load balancing, like when we host any particular website or web server to serve image applications. So on that, what are the challenges, and what are the new technologies applicable for this load balancing and this traditional mechanism also? Both the things I am going to highlight. So in my presentation outline, I am going to give the details of this overview of data dissemination. So data dissemination is basically when we have set of data, and when it goes over the internet, what are the challenges what we face, or what are the interfaces are there. As we know, it is basically one web server, or but in between many security mechanism and many type of load balancing happens. So here my focus mostly it will be under what are the conditions we have to consider for the details of this load balancing mechanism. Then the second outline will be load balancing needs. So what are the needs and why we have to go for it, and different methods in web domain. And then some of the system reliability, architecture, and capability also I am going to highlight, because ultimately we are doing this load balancing mostly to keep the system highly reliable, and it should be available always for the users. And then distributed data center, of course, this is again when we have multiple data centers, and in that how the data is distributed across the nodes, and how the algorithm works for the different data centers. So what are the logics implemented, and how this new role of machine learning, particularly on the load balancing, when we say the load balancing and applicable for what are the endpoints, like for an end user it is looking like the data is coming from the server, but in between many places many devices are there, like we have this router, firewall, or the when switches, many even that ultimately data is coming from the storage backend. So what are the different mechanisms are used, and how this set of data is used for this machine learning activities to make a faster decision in the web server. So that thing I'm going to highlight. Then data center monitoring and user data analytics, that is also again whatever the load balancing algorithm we are going to discuss. This is all basically input is coming from this our monitoring, and that is a proper real-time monitoring, and this data is being used for the taking decision and making the real-time decision. So monitoring is also is very important part which plays role for the when we go for image streaming activity, because these image streaming applications I'm also going to in detail. So what are the challenges we face when we thought of giving the streaming of the web services, and because of that this load balancing mechanism over the machine learning we are thinking of today, and then ML approaches for web streaming of image service applications. This is the main focus I'm going to give today, because image is basically a bulk data set of data will be there, how we are dividing this data, and then this data when it flows to the outside, so in between devices are also are there, like your internet line which plays a major role when it comes for hosting. So there also how this balancing happens, and all these models I am going to present today, basically the set of devices where the data is taken as input for this load balancing consideration. And of course this towards the last I will just highlight on this machine learning based load balancing implementation also, like how it will be implemented as a model, and how that will be taken into the real-time streaming operations. So coming to the overview of data dissemination. So as we know, the data will be residing in the storage. Here I am taking a satellite image because this is the input data I have considered as images. And then elevation and thematic, this means like we have some data which will be database driven, and some data which will be like unstructured data. So here I am considering this data of satellite images as unstructured data, and the elevation and thematic data sets also, depending on the nature it can be structured or unstructured data also. And this all data is being stored in the optimized storage. So in detail also I am going to say give that all these concepts how this data is being basically stored, and when it goes from one place to another, like data is there in storage, and depending on application it will go to the server, then to the end user. So while traveling between the two devices or two nodes, or ultimately to the users, what are the traditional methods or traditional storage devices, what are the concepts are used, and how this machine learning is also applicable as a whole, like and the data when we go to as a storage also will have again redundancy like multiple nodes or multiple disks, those type of concept will be there. And then that data will that data will be taken the model input. Then server also will have again it will be multiple CPUs or multiple core devices. And then while handling the multiple core of devices, how this data also taken input to the machine learning model. And then of course when data goes outside through a secure mechanism, that is firewall. Or I have another presentation particularly on the security part. On that also I will mostly focus only on security. So there we'll get a clarity when it comes to web application, what are the security mechanisms we are following. And those data when it is going, and these all individual devices data will come as input to the machine learning model, so that that model will take a decision. So which path of the, or which port of the storage, and then which port of the server, and what are the path algorithm it has to follow, if it is a hardware based load balancing, or if whatever models it has to follow, if it is a going through active passive firewall or active firewall, because we can configure devices into many ways. So this basically this slide what I am trying to show here is the end users, they will get data from the internet sources, that is the landing point is the router for the data center. And in between we have multiple devices which will cater the data and to send it to outside. So this is basically one overview of this data dissemination model, and on that how this machine learning will be applicable. Now we'll go to details of that. So here I have shown this Webwork Stinger architecture. Now, as I shown in the previous slides, when I say internet bandwidth, my bandwidth I can take 2 to 3, 4, or whatever possible number of internet lines, and how I will serve across them. So that is also one type of load balancing happens, because when we have multiple links, and you will take you will check through the algorithm which link is giving me less latency, which link is giving at that particular time more loaded. Those type of algorithm is a input to the machine learning model when it comes to internet bandwidth. So similarly, this router is a endpoint for this internet connection. So depending on the number of lines, we may have number of routers configured. Router configuration is there. So when multiple configurations are there, then what are the logics has to be followed for this load balancing? Those type of decision will be taken as a model to this machine learning model. Now this router data is goes to the because the endpoint is landing from the internet to the router of the data center. Then they will land into a secure environment like network firewall, or then this intrusion prevention systems or web application firewall, which are I'm just giving the idea of the practical setup what is being used for the web hosting architecture. So here this web application firewall also, which generally as a developer we use web vulnerability scanning tools, but in data centers there will be hardware appliances which will be called the web application firewall, and that is basically to check the signature of this vulnerability in your web services or in your code. So based on that it will create the protection mechanism. So there also multiple ports or multiple connectivity is there towards the outer side, like firewall side, and towards the inside the data center side. So in that case also, when it data is traveling over the multiple ports, so what should be the logic to be applied for proper data transfer? So that is another input to the machine learning model. Then and this data is this request is landing into of course it is on hardcore switch will be there, that is on core switch, and on that multiple servers will be there, because multiple servers, when we have big data centers, there will be multiple data centers, then tiering of uh, switches also will be there, like you will have core switch, you have distribution switch, those kind of things will be there. So when numbers are bigger and your ports are also multiplying in that factor, then this load balancing comes into picture. So it is basically to monitor each and every port and each and every device real-time functionality or real-time utilization. Based on that, it will take a decision that what type of algorithm has to be followed. So in traditional load balancer, what happens, here I have shown in between server load balancer. In traditional load balancer, what happens, it will just check the health of this parameters based on static algorithm. I'm also going to focus what happens in the traditional load balancer and what happens in the machine learning load balancer. So there will be fine-tune comparison also is there, and on that we can discuss some more in our details. Then this then comes to the server cluster as I said. Yes. Yes.
Sorry to interrupt. Please maximize the PPT. As so many participants cannot see the PPT, please maximize.
What happens here?
Yeah, this.
You're able to see?
Please press the F5.
No, that all I'm doing that.
So this is
Think some
again.
problem. I'll just close this and no, it's not visual is telling, no?
Please maximize.
Yeah,
please press
actually
F5.
I'm doing that, but something is problem with it. No, I am doing that, but I think problem is there it is visible, but selling something problem is there, no? Okay, what will do is
Okay, sir. Okay, please continue.
stop sharing and start sharing again. What is that? What is that? These are the problems I was telling. Why this is coming here?
Yes, I
This type
again.
of screen, why it is coming?
Previously it was okay.
Let's check there. Okay. Something. Huh? What visual they are? They are telling not visual. You are telling. The system problem. This is. You don't know. That's what I told. There is some problem there. I will do one thing. I will do one thing. Huh? Where it is visual that just.
sir, yes, sir. It is okay. Hello.
Is it okay now? Yeah.
Yeah,
Is it
yes,
okay?
sir. Okay, sir. Please proceed. Please proceed.
Yeah. So, okay. Now I was explaining about this the different devices where this data is coming for the model, that like whatever we are discussing, load balancing model using machine learning. So this is I was discussing about this group of servers. So depending on the number of applications, there will be a cluster of servers, and this server cluster will be used as a like the server load balancer will be there, and from there also, depending on the algorithm, and the traditional load balancing happens like I'm going to present on those algorithm also. Then this cluster of servers are then configured in the backend to the storage. Then storage, again there will be multiple controllers in the storage and multiple number of storages, and how to build them across multiple storages into a single cluster. Those type of activities, when it is involved, then this load balancing comes into picture. So what we got here is, like, we have multiple set of data across these devices, like internet. Multiple internet line input, multiple firewall, multiple intrusion prevention algorithms are there. Then different types of switches will be there. Then cluster of storages, that is also one input to this model, ML model. Then our storage, like we have many different type of storages will be there. So these all classification also I am going to present in my coming PPT. And there we can see like what are the data sources which are giving input to this machine learning based load balancing. So now we'll focus on this load balancing needs. So as we know, this process of distributing a set of tasks over the set of resources. So here what we discussed is we have multiple set of devices are there. And when we go to go for any kind of a streaming application or hosting application, there the multiple devices are involved in the backend data center, which is giving output. So there all the devices data, how they will be distributed across all the resources available in efficiently. That is how is the fundamental thing. And then how this all the devices are handshaking with each other in an efficient way. So that is basically load balancing can optimize the response time. So for the end user, of course, this response time is the most critical thing, which we have to do the main focus while designing this load balancing algorithms. Then and of course this load balancing, the request or connection of these devices, which one of the thing which is getting access and getting the input to this load balancing. And then of course this to cater and serve data efficiently. So here some noise is there. So this load balancing, it basically do request or connection balancing, of course, and this data balancing also. What the data is flowing across the devices, and when it comes to the multiple sites, deliver the data across the site efficiently. So that means we have multiple sites. Then how the decision algorithm will be there, which will cater this data to the different sites in a effective manner. And as I said, the load balancing is basically we have to cater two things. One is the data which is really flowing over the all these activities, and then request is basically to get the data to the end user. So these are the main concept for which we are doing this load balancing. And this load balancer is again, as we know, it can be software or hardware load balancer, and in detail I am going to present this software and hardware load balancing features, and how this the different devices input is coming to this ML algorithm. There we take a common decision, and that decision will be applied for the end user. And when we talk about the hardware load balancing appliances, and we as in today the traditional devices are available like link load balancers. That means this internet line will be there, and this internet line multiple links will be connected to this link load balancer, and for the end side of the data center, it will be clubbed as a single network. So that means there will be a different set of public IPs from different set of ISPs will be there, and those all will be terminated into the link load balancer, and towards the data center they will be converged into a single network. So there we have that is one way how this hardware load balancer works for the internet line. Similarly, the server load balancer is also there. That means the request which is required for the cluster of servers, then this server load balancer will check the health of the servers, and then the health of the server, depending on that, it will take one common decision, and the request will land there. But these all are happening in an individual device level. That means the server load balancer, when it takes a decision and one request goes to one particular server, then next request, depending on the state of the session or state of the load balancing algorithm, and that request will be diverted to different servers. But when we talk about machine learning based load balancing, it takes input from different devices. Like it takes input from our link load balancer, then server load balancer, then third one which I'm focusing here is the global site load balancer. That means we have multiple sites, then each site will have its individual load. That also has to be taken as one input for this machine learning based load balancing. So what basically here this global site load balancing does is, once the DNS query which is getting resolved, that will be based on this GSLV load balancer health status. That means it will check the health of these devices of individual servers. So when we go for hardware appliances, this does at particular level, like link load balancer does is in a network level, and then server load balancer do the health checking of the server level. Global site load balancer will check the health of the server load balancer status level. That means how many servers are loaded with what type of applications or what type of load on that particular site. So these are the traditional devices available as hardware appliances. Now, this relevance of the load balancing for image streaming applications, which is the main focus here for us. So what happens here is, this data associated with load balancing is, as I said, this internet bandwidth, then switch port level data also, like the data is coming from the internet line to the end users, and then towards the data center, it is having multiple devices which are connected through multiple switch ports. Each switch port status also is one input for this load balancing, and which generally traditionally do not happen in normal server load balancer applications. So here the data associated with load balancing here classified as like your internet line, which is the bandwidth between the your data center and public facing, and then switch port level is like a local data. So local, all the devices are interfaced through the switch port level. So port level information is one input for this model. Then server request and server ports. So this server which is giving access particular application, so each server also behaves differently depending on the load, or depending on the type of CPU memory, because in data center various classes of servers will be there depending on the brands or depending on these configurations. Suppose we go for today 8 core processor to CPU servers. Then due to system upgrade or system a new phase of upgrades, then different set of servers are coming. So that means all this core information, CPU information, all this are the input to this model, which generally in server load balancer happens only server inputs are taken as decision making. But here internet bandwidth, switch port level data, server information also, and the most important is the storage data. The storage data is when we go for image hosting, the data multiple of storages, like multiple number of storages are involved. That is because the size of the data is so huge and the number of files what is getting resided in the storage is very high. So that way, when multiple devices are involved, that data paths and data bandwidth, like what interface this storage is connected to the servers. So each port level bandwidth information also is coming was an input to this model. Now, as I said, the traditional load balancing, what happens in server load balancer or any kind of network load balancer or global site load balancer is like, as we know, different type of algorithms which are there, which we know all this algorithm. This list connection, round robin, weighted round robin, CPU utilization based load balancing, then memory based load balancing, then bandwidth, like what are the, suppose in your data center, there may be a different bandwidth internet connections will be there. So how to make a use of this, all this together as a efficient way, and so that way this works. And then the stickiness based, like once you access once the request landed into one particular server, the request will be completed there till the end. So this type of algorithms, which we know it is available in traditional load balancing devices for this link load balancer or server load balancer or this global set load balancer. But here, what we focus more here is, apart from these devices, how this other input data is involved. Other input means like storage level information, then net port switch port level information, then all together how it will be used in a decision making algorithm to take a common decision. And ultimately this the most important factor what we discussed is response time, which has to be considered when we do any type of decision making algorithm. Now here, this I'm going to mainly highlight why we are doing this type of machine learning based load balancing, and that is basically to strengthen the process and to bring reliability and capability to the platform. So what are the main important steps are there, like data center monitoring? As I said, monitoring plays a very important role because the monitoring data also comes as an input to this model. And then what are the different monitoring generally happens in the data center? What I have highlighted some of the things here is like server response monitoring, then scheduling the alerts and request or response time monitoring for each and every devices, infrastructure monitoring, that is basically health of all the devices. And apart from that, this is a little bit analytics in local level, like what, how many number of users and what are the how many visits or unique IPs are there, or daily hits, then data transfer, what happens regular basis. All these are input to this model. And then application analytics also. So, and that is basically when you have crowdsourcing applications, then where we have to put control to get an effective way for this load balancing. And then the pattern, like what are the maintenance schedules, what we are following, those things also plays important role. Audible? Mm. Am I audible, sir?
Yes, sir.
Yes, sir.
Yes,
You are
yes.
Continue.
Okay. Thank you. Yeah. So here, as I said, this the strengthening of the system infrastructure and reliability. When I say that is why we are doing load balancing. So here, the most important factor comes is optimize and maintain health of the infrastructure. So the other particular D1 input for this. And the model of this algorithm, load balancing algorithm changes because when you have, let us say, 4 or 5 servers for a particular service, and due to certain reason, 2 servers we have taken out, and that is becoming input for this model. So those type of step happens when you go for machine learning based load balancing. No, that is basically what I am telling. So optimizing steps create a high availability. Steps create a high availability. Hmm. Think some noise is there. Hmm. And some noise is there. So, so, okay, now this, as I said, the high availability. So when we do load balancing, then at any point of time there will not be request will be ensured for the end user. That means any particular server is, but during the operation, suppose user has already logged in and he is continuing some session, and due to some activities or some other reason like hardware devices failure or memory filling or any heavy load in particular server which request is being served, so immediately this decision algorithm will be changed, and that will divert on the fly request also. So that is basically to create a high availability and then increase and scaling of the infrastructure. So when we go for multiple bigger scale of data center, there will be multiple servers and multiple storages and many switches and, or many devices will complex and configuration will be there, on which we have to no mandatorily go for this machine learning based load balancing, because to take effective decision, because as on today this hardware based load balancers are functionalities are limited. That means we can do at least internet based load balancing or any server analysis like server CPU or memory or those kind of things we can do, but as a whole there will be no uh, as a whole there will be not be any decision algorithm. So here we are focusing basically what are the new technologies are used or going on as on today, where this web streaming of the applications, and there it plays a major role. So again here I'm going to show the system setup that like as I highlighted earlier, that in the typical data centers there will be multiple servers or will be in terms of hundreds or thousands or lakhs also when it comes to a bigger data center. Then as I have shown here, this multiple internet lines, or it need not be redundant, it can be in traditional data centers they will take input from all the ISPs. So all the ISPs are ensured, because this is all to ensure that availability of the services are to be there. So that way all the ISPs input will be there, and that will be taken as a model to the input whatever I was telling. Now Similarly, there will be many security devices also are involved, or many class of tier of switching also is there. Then traditional load balancer as a telling, then application server. So here I am referring application servers is basically the all the request what is getting a result using the type of application. So here in again cluster of servers will be there in that database servers, and you have many kind of FTP servers or authentication servers. So multiple servers will be there for each activities. So that way these all will clustered, and then they will be connected in a heavily like multiple sources to be connected to different class of storages. And here what I have shown here is in storage also will have different class of storage, as we know, depending on the technology. We have now the SSD, SAS, SATA, or NLSAS, or any backup devices which will be there in low performance storages. And apart from that, there's backup traditional type libraries also will be there. So when they all are connected into the network, then here it brings complexity for the decision making. So thereby we have to take input of multiple devices. So how efficiently or that particular request will be solved. So here I am trying to show the complexity of the data center when it comes to web hosting. And here I'm showing that the one data center will house this type of components. Then when you have multiple data center across different locations, then all are connected over the internet to host the same application. Then this global site load balancer comes into picture. So this complexity is there when it comes to distributed architecture, because and there the same data will be hosted in different locations in the same time. Then here I am trying to show the global site load balancing between the two sites. So what happens here is each side there will be local servers will be there, and then database servers will be there, and their own storage and local volumes will be there. And similarly other side also will have their server same. Sometimes it will be same application, or it can be scaled version also. That means suppose the primary data center will have let us say 10 servers for a particular application. So second side it may not have all 10, it can have 1, 2 or 3 servers also. So that way the proper balancing also may not be there, but that type of action also will be taken here by global site load balancing. So global site load balancer, when it that takes input from the server load balancer, that means the server load balancer will have its own information of individual site, and then similarly other site also it will have its own individual information, and then this data will go to the local global site load balancing, and then this primary site data also will go to their primary global site load balancing, and they will in turn handshake between this information, so that the when the DNS query comes from the internet, then anywhere it lands, from there the GSL will guide when it comes to the load balancing across the global site load balancer. But what happens, the once this global site load balancer gives the information of the local server information and the user continues, then in traditional load balancing mechanism this happens one time, and that user resets there till his request is complete. But when we are discussing about ML based load balancing, so it can change, because when the user which is doing his action or his request is being completed in particular data center, that need not be constant throughout these sessions. That type of information also we are giving here as a input to the model. So that way this mechanism works. Now I'm going to focus mostly on this machine learning based load balancing. So here what happens is this, as we know, any type of machine learning algorithm, there will be input data model and there will be analytical model. So here I have just, I'm trying to show what happens in a particular sequence, the gathering of the data, then data preparation. Data preparation is basically to take decision, there will be some particular common format will be there. Then data wrangling is like if any alteration is required to do a particular algorithm, those type of wrapping happens here. Then analysis of the data. So once this all type of algorithms are designed, then analysis happens, then train the model. That means this data will come as a input, and then test model is basically whether this whatever we designed, that validation will happen, then it will be deployed. So these are the basic steps what is involved when it comes to the machine learning based load balancing. And the basic requirements, as I highlighted earlier, it is basically the data which is coming from multiple sources, and that data will multiple sources means, as I highlighted, that is the internet line, your firewall inputs, your switch inputs, link load balancer inputs, then server load balancer inputs, and server inputs, then classified of storages are there. Each storage input, those all are coming as input to this model, and it is taking a decision, and this happens in a fraction of second, because ultimately, as we are doing all to improve the user response time, so that way we have to validate this using a test model, as I told. So before deployment, we have to validate that whatever actions we are doing, of course, it is giving a response time improvement. So here the data and analytical model, then prediction algorithm. So prediction algorithm, again, it is designed using various type of codes, and then validation and feedback. So then this validation happens once we before deployment, and that will be taken any type of feedback required in during this model building also, that will be considered as an input. Now, so what do you need to use this ML is basically when you do the set of data, then this data is basically taken into some chunks, and this each data is taken as one job for a particular algorithm creation, and then it is all being stored in a different as a worker. What I have mentioned here is it is basically small programs which will do the individual jobs, and then these all will give a useful information. So I am just highlighting here the compute and storage information, how it is being taken from different port level. Like here, multiple paths are there. That means different ports will be there, and that particular data will be taken as a individual small sub program, and then each sub small program will be taken into a consideration as a whole to take as a useful information. And again, I am giving very fine tuning to the CPU core level also. So here what happens, in the previous slide I was giving the information about the port level, but here I am giving some more details about the core level also. What happens even local memory level also, system memory, as we know different levels of memory will be there in servers, or like L1, L2, L3 memory, and which we know all and the standard practice. This information also is coming as an input to this model. So when we select a CPU based load balancing, that means which CPU is most loaded and which CPU is less loaded. This type of information is coming in a traditional load balancer. But when it comes to ML based load balancer, at the same time it will consider with other devices input also, which I was referring. So, and this is being a CPU, and then similar action happens when you have graphics processing, that is GPU. So GPU, when we comes to image processing applications, there also GPU plays a major role for any kind of real-time analysis or any kind of image processing applications. So the graphics inputs are also considered as a input for this decision making. Now, when I'm showing this operation, what happens in abroad, because I have now highlighted that what are the actions happens when it comes to load balancing. So here what I'm telling is the dynamic configuration. Sometimes you will have one particular algorithm which will be running, but due to certain changes, that here that changes only I am highlighting as the dynamic website hosting. That means changes is means like you have a crowdsource applications, those type of things, when data size increases or data limit increases, those type of information is coming as an input. And then troubleshooting, as I told, troubleshooting is basically when we have 3-4 servers and one or two is getting down because of some reason, that input is coming. That is what I am meaning here as troubleshooting. Then your security device operations also. So security, as we know, various levels of operation happens for the security, like firewall, IPS, and then web application firewall, and the log analysis. So these all input also comes to the model. And finally, this device level monitoring, like when we go to in bigger data centers, there many devices will be there and they all will be monitored in a single dashboard. So those type of inputs are coming to this model. And then augmentation or any kind of new upgradation, like I told, today we have some 8-core machines, and due to technology changes, we will have new devices to the data center, and those things also will be considered for this model, because the impact of this technological changes also is very much we have to assess properly when we give for a particular response for a particular services. And benchmarking and performance testing, that is most critical thing. Like each devices will have its performance and benchmarking figures. When we do any kind of request balancing for the users, then we have to see the industry benchmarks, like whatever we get particular output in a live scenario and what is taken as a benchmark for these devices, there should not be much trade-off. That means when you know that one server can handle 40,000 connections, then it should not be in practical. When it is live in data center, it should not give a much degraded performance. So those type of inputs we have to monitor constantly, so that we can really correlate whether it is a device level problem or load balancing algorithm problem. So those type of benchmarking figures also we have to keep as input to this. And user or log analysis and data analytics, which is again most critical, like whatever number of regular users, for them what are the tuning we should do, or if any spike in the users, or any particular trend or seasonality in the users, those type of inputs we have to give as a input for this load balancing. So in summary, like these data sources for the ML based load balancing is, as I said, the request based load balancing happens in this link load balancer or server load balancer or global site load balancer. So there are two events happens here, like as we know, it is all this happens over the HTTP protocol. The request we have to resolve, and this all session information and all will be part of this devices. So these devices will keep its information for the request balancing. Similarly, when it comes to data load balancing, that is storage. Again, here what I told is different type of storage, and each storage will have multiple controllers. Then all interfaces has to sync among them to give a better performance. So this type of data load balancing happens when it comes to data level actions. Then data replication, and when we have multiple data centers, and we have to keep one place and the same data at the same time in other place. So this load balancing algorithm also recognizes that whether this similar data is available or any change is there in that particular data set. Till that time, request will not go to other side. So this type of decision making happens when it comes to data load balancing. So as we know that same data is hosted in two different data centers, then this will be very useful for any kind of decision making. Similarly, database replication, and when we handle multiple data center database servers, among them also, as I told, it happens between the two different sites in same data center. Also, when we have multiple database servers for the same action, then it is another input to this model, and it will not allow for the end users till the all the data is available one to one in the same database levels. So this type of action happens, and which is not in general happens in the traditional load balancer, because as I said, the traditional load balancer will have its own algorithm, and which will be mostly based on this, focusing on the towards the server actions. So it will not do any kind of action based on this what we're discussing, like port level information or data level synchronization, those type of information, which still one current limitation. Then feedback or monitoring data, that is again, as I told, most critically is when we do any particular algorithm, then that data, this is here why I'm mentioning as DC monitoring, like data center monitoring data. So data center, we know this many devices will be there, like your server, storage, firewall, switches, and then internet line. Those type of devices monitoring, that is that data is taking as input to this model. And then database, of course, the structured data which is there in our database, and those type of input also will be coming to this model. And then compute, and they shown earlier, all this compute devices will have its CPU or individual core level information. Then storage information, like how many ports are there in storage, how many controllers, what type of disks are used, how many interfaces are connected to this storage. Those type of information comes to the model. Then similar action happens for the network logs. So this is basically the data sources which is most important, like these are the input sources which is being taken as a input data to this model. Now here I am going to show this data center activities, what happens, like because once we know what are the because this type of analysis of this machine learning based, all are data driven. So all this data information sources we have to explore, and that will be fed as the input to this model. Then here I'm just classifying some of the actions are developmental and some of the actions are operational. That means in operational scenario, the changes, like periodicity of changes, will be very low when it comes to operational activities. But when it comes to developmental activities, there will be many fine tuning happens in a regular basis. That is the main classification here I'm trying to show here. And in the systems and network configuration architecture, then so suppose you have one architecture today, and after two or specific time period there will be changes, then that will be taken as input. That means whatever model we have designed, that will not valid for when is the, if there is any changes in the configuration. Configuration means it need not be always like change in server or change in storage or any kind of devices which is used. but it is basically architectural changes like different tiering of storages. That is one architecture. If you have one class of storage, that is one architecture. So those type of changes we have to very much consider when it comes to the proper decision making. Then load testing. So the load testing is basically when you have one particular website hosted, that we have to periodically check load in different scenarios. Different scenario means like when you check load with some specified users, let us say X number of users, then you will get one performance. When you will get 2x users, then you will get another performance. So those type of inputs also that happens in developmental activities. So in that we have to keep these inputs as a input model. Then performance analysis and fine tuning. So let us say due to the new devices, when they come and sit in the data center, they will have some predefined configurations, and across uh, use cases we come to know that there will be fine tuning of these devices. Whatever model we designed, when the initial level comes, any changes, particularly change, what I am trying to say is, one is configuration level changes or device level some changes in terms of capacity, like increase in cores, increase in memory, or decrease in memory. Those are inputs to this model. Then web application vulnerability checks and security architecture. So security architecture and what we are designing is like we have to comply basically security vulnerability rules, and towards that what are the changes required, particularly changes required means either in code level or any kind of device level, like in blocking inputs or in the firewall, those type of things also change in configuration for the security level. So that also is another input to this. Then of course this operational, as I told, which is not frequent changes happens, like your accommodation and optimization of systems. Then dynamic data update, that means if there is a known thing which is going to come. So your model is today it is built with a particular framework. You know that every 2 months there will be data updates, so that is again input to this model. So those type of decision, some changes can happen dynamic, or some changes can happen like based on this developmental mode. And then monitoring of the systems, we told this is all our operational activities. And crisis management, like when you do any type of periodic maintenance and installation, commissioning, whatever happens, so during that time also, due to any changes, what is the impact that has to be properly given as a input to this. So here again I'm trying to show in data center operations, like you will have a copy or backup. Due to this, what are the effects? And then whatever software version upgradation happens also, then firmware version upgradation happens. So due to that, any impact on this particular device performance, those type of inputs are taken. Then monitoring, as I told, monitoring, of course, monitoring plays a major role, and on that inputs are taken as feedback for this model. And then different type of support activity. Support means like when we do any one particular fixed model, and on that, due to any changes in firmware or changes in data sizing, those type of things happens. So that type, what are the changes we have to do for this model, that only I'm referring here as support. And then routine tasks, whatever is there, that is all considered as a input. So here I'm just going to say what are the data center monitoring and user and data analytics happens, and how that affects our load balancing. That is I'm going to highlight. So what happens here is, like you will have multiple set of data will be there. Then you will have a log collection server will be there, and in that you will take all the data into a database, and you will create a output which will give you the number of connections, throughput, response, all these resources. So what we are referring here is when I have a particular set of data under certain environment, how those that how that affects for the number of connections or a particular device throughput, response time, those type of figures we can simulate in individual device level. That is what here I am meaning as monitoring. So that once I know that this device performance is like this, then that parameters are given as input to this model. And of course, this web analytics, what I'm referring is, you will have a study of the pattern of these visitors, then different type of information collection mechanism is there, like you will measure an analysis, then you will collect all this information and reporting. So that means you will take all these inputs, and that input will come as a information as the feedback to this model for taking a better decision. So what are these inputs which I am going to highlight here is, you will have server farm statistics, then timestamp data, like what time user have accessed, and this user hits, visits, real data transfer, and web page accessed, user location. These all parameters are one input to this for taking proper load balancing. So here another inputs are like most which layers are being most largely used, then who are the top users, what the peak time, what is the time mostly many users are coming. So based on that particular time, we may have to create a auto algorithm which will decide that particular time we have to see that many servers or many resources are allocated automatically for that type of action. Then server wise statistics, each server how it behaves. Suppose you have created a model in a particular day, and you got some X performance due to degradation of individual components also, this may affect. So that type of statistics or that type of information we have to monitor periodically to get a better output in this model. And search for features to analyze traffic, IP pattern, like what are the IPs or IP location also, like whether if they are coming from different locations, and what are the response. Suppose we get many codes like error codes or success codes in HTTP status, those type of things also you have to take input. And towards last, security inputs also, like vulnerability or any changes in firewall configuration, port level configuration, those type of information we have to give as a input to this model. Now I'm just highlighting some of these screens which is showing like why I need the user information, not monitoring information. That means here we can see just in graphical picture it is showing that how these users are concentrated in various part of this geography. And similarly server wise, so which server, so any particular server is less loaded or more loaded, this type of patterns where we have to take as input. And within India also, which region is mostly largely accessed, those type of log format or access format is being taken as input to this. So now coming to the machine learning approach for the web streaming of the image service application. So until now I have just highlighted what are the algorithms and how this decision making happens at a different device level. Now so here I'm just highlighting some of the basic things which we are having for that one portal, like we have multiple of servers and some storages and then backup mechanism, then load balancer at local level and GSLB, that is global site load balancer, then IPS, IDS, and this firewall network components also there. So more than many applications are being hosted. So the meaning is when you go for complex architecture, like you have multiple devices are there and multiple applications are there, there we have to create a proper input from all the devices, and we have to build a model which will take load balance. So while building this model, as I told, what are the input data sources required from different devices, as well as monitoring and security devices. So here I'm just highlighting what are the key areas when we design any type of data center with proper load balancing. So the considerations are like what is the application we have to host, and what is the type of data to be hosted, that is structured or unstructured data, and size and volume of the data to be hosted. Then compute size, like what is the number of servers or number of storages we have to take a proper note of it. And then security device requirements, monitoring tools, like as I told, that is plays a major role, which will give the input to the real-time environment, and that real-time data will be taken as a feedback more to this model. And then user analytics, like the user pattern behavior, those type of data also is coming as input to this model. And then internet bandwidth requirements. So when I say application to be hosted, that is again each area, like application to be hosted. So whether it is a dynamic website or static website, whether it is any static data is there or any crowdsourcing like mobile applications, or any data which is continuously getting input to your data centers. So those type of information also required. And then sticky or non-sticky applications, like for certain applications, as I said, the continuous particular server needs access to complete the request. So there we have to consider sticky and non-sticky operations. Then access mechanism. So access mechanism is again whether you have credential based operation or any open, without any credential, those type of inputs also. Then IO intensive or throughput intensive, like when we sort the data over internet, the throughput and IO, these all are trade-offs for particular infrastructure. So as and when we design a data center or any kind of application we host, whether it needs IO intensive job or a throughput intensive job, that is all being taken as input. Then service criticality, like whether it should be what is the type of server and type of data storage required. What I mean by type of server, type of storage here is like the server, different type of servers are there which will never go down, like one-to-one redundancy will be there in terms of hardware, software, whatever we mean. So similarly, storage also, there will be enterprise class storages will be there, which will have multiple process, multiple even hot standby disks, and multiple controllers. Every device level pin monitoring, redundancy will be there. So this type of inputs are there. And then type of data to be hosted, as I said, structured or unstructured data. Then data integrity, like how is the classified data is there, whether it is a small chunk of files or bigger block of files are there. So based on that, or it is a mix of files are there. So based on that also, this performance will affect. So based on that, this I am giving as input in a granular level, because these all information required for this ML algorithm, machine learning based algorithm, for this load balancing. So once, because these all information is very much available, and that information just we are giving as a input to this model. So again, it is encrypted or non-encrypted data. That is also information is required. Then server or volume data to be hosted. So whether it is static volume or grow online, like as I said, certain storages will have limitation to grow online for a higher volume. Like we know the traditional SAN or NAS devices will have its limitations for a single run, how much maximum size it can happen. But what happens when your data grows? So thereby we have to bring this file system into concept. So there we can have multiple level of like we can create bigger LANs, what are the traditional storage is having. Then data backup requirements, like whether the storage is taking any snapshot. If it is taking snapshot, then that overhead we have to keep minus for our data model. Those type of actions also we have to. Then data deduplication consideration. So when we know the storages, when they do additional jobs like snapshot, deduplication, those type of jobs, when they it happens in the storage, that is one overhead to the storage, and that overhead also we have to give as input to this model. And then here comes to this compute. So compute also compute when you go for computer resources, that is per user or per instance space, how many users it can handle. So based on that we have to use decide the compute resources. And then benchmarking features, like as I was explaining sometimes before, the benchmarking figures are very much available for different type of standard products, like storage, server, firewall, or switches. That is called standard performance evaluation corporation. Maybe we can Google it and we can see more details how these different devices, some benchmarking figures are there. So in our model, we have to give this benchmarking figures as one input versus the live environment. What are the figures we get? So those two trade-offs will be input to this, and that will create the output whatever we desired. Then load simulation, as I told earlier, and that load simulation is open source tools are also there, but industry running many tools are there, like load runner, web inspect, AppScan. So many tools are there which will create input to this model. Then storage volume. So as I told earlier, the storage volume, whether it is in NAS or SAN, then whether it is file system based or independent of file system. And any benchmarking figures, like as I said earlier, compute benchmarking, similarly storage benchmarking figures are also available. And those since before any product release, there will be some benchmarking figures. Those benchmarking figures that will be available for different products, and we have to take as input. Coming to the monitoring tools, that is infrastructure monitoring, resource monitoring, and this user monitoring. So infrastructure monitoring is basically all the devices, how they work, and how that will be when they work integratedly, like individual device performance, and when they connected back to back, how that resources are operating. So those type of infrastructure monitoring inputs are also very much required for this decision making. And user monitoring, and which I highlighted earlier in slide also, like all the statistics of this user's location, IP, and their behavior, user hits, all these informations are required. Then security operation, like this is again one critical area where we have to give data to this model. Like security operation, it happens in different device level. We have network firewall, IPS, that is intrusion prevention system, and then web vulnerability scanner. Apart from that, we can have um, we can integrate these scanning tools also to certain devices. So that is that happens. So those type of inputs also we have to give as a model. So next is the user data analytic tools like bandwidth prediction. So let us say we have one current bandwidth which is really consumed, and what will be the coming 1 year, what will the prediction. So those type of prediction data also will come for this proper load balancing mechanism. So future storage volume estimation, future computing requirements, then bandwidth and network expansion. So these are the things which when it comes to do a proper decision making. And they showed internet bandwidth also, then that will have some parameters like latency figures, then whether it is one-to-one connection or it is multiple links. These all are granular level inputs required for this ML based load balancing for this image streaming applications. And yeah, as I said, there's major consideration again I'm highlighting, that is the server virtualization or storage volume. That means you have multiple servers or you have multiple storage or conversion infrastructure. Like in a single unit you will have server, storage, everything, or any kind of data duplication is involved in data analytics and user analytics. So these all major considerations which we have to go for when we consider this input model for this analytics. Now coming to this requirement, like why we are building this machine learning based load balancing, and what is this requirement for this analytics. And here I'm just highlighting 2-3 PPTs, that is for requirement of AI for these data centers. So what happens is like the customized chips also available, which will monitor, or it will take in different data standards from for that individual devices. So what happens here is there will be standardization and things are there, and standardization of this input data format is there. So here in this slide, basically it gives a highlight is, since AI customized tools are there, then we have to move everywhere automation, then we have to move everywhere we have to maintain some standards. So those type of inputs, since it is very much available, so this is becoming the trend for this coming days. So that is why we are building this ML based load balancing. Now the problems what it can solve here is like it can give a better prediction. So events that are affected by many variables. So here what we consider as variables is like my change in network, change in internet bandwidth, change in my computing resources, or changing my server resources. Those type of things it can better predict and it can give proper. So there will always be stable output for the end user. So now when there is a non-linear relationship is there, so that type of events also it can better predict, and it will give us alert that this is due to this particular device addition, this user response drastically came down. So this type of information also will get from this model, and then learning from the data, as I told, monitoring and this analytics, those type of operation also needs a very much for this, and then feed data, whatever analytics we are doing, that will come as a learning from the data. And anomaly detection, that is any kind of event happens, so it will because we have built a model with all the input data, so any kind of any type of troubleshooting or any kind of events also, this model can give us very much input that because of this event this action has happened. And the major challenges just I'm going to highlight here is like all the data centers are not fully automated. So in that case, we have to how to collect this data from different devices That is, of course, one challenge. And it may not be any granular level, at least whatever devices information is available, port level or different device level, those can be collected. And we are thinking of like many automatic robots that will take as for different kind of actions. That is also those type of challenges were to happens in the physical device operation. These are the limitations generally which still exist. Within that, we have to build our models. Now, the concept here is why, how we do this. So it happens basically we have to collect the source of data like different sensors which is already built into those devices, and we have to integrate only this sensor input data to the model. So whether, and it is not so dynamic, it is like it happens in a different level, like each devices in data when it comes, it will give the user routing will happen among the devices in such a way that user response time will always be ensured. So here just I'm giving overview of how it happens for these power trends, like when we go for load balancing for the power. So power, when we know the multiple devices are there, which devices is consuming what and due to what reason it is consuming suddenly more power, those type of information also we can get from this model. And again, the cooling also, like whether power is it uniformly loaded, uniformly distributed across the data center, or what are the major hotspots are there in terms of cooling, or those type of information also we can get. And this type, when we get multiple information about this these data center activities, then that will again impact to the end user in terms of life availability and in terms of response. So again, I am going to show here like how can the data center professionals use this artificial intelligence, that is server placement, like where we have to position this rack, what type of power and what type of cabling, cooling or fire suppression has to be used. Those type of information, it will be taken as input, and because of that you will get a better performance in your data center. So those type of information we can get from this. And then as I said, prediction, data center operations prediction, basically any equipment which is going to failure or any network level uses. So this type of information when we can get, then that will be more useful for our day-to-day operations also. And troubleshooting, of course, the troubleshooting operations when it happens, then that troubleshooting inputs also is taken as input to this model. And this is basically DCIM, that is data center infrastructure monitoring. So what are the infrastructure monitoring solutions are available and how they will be used for different type of failure prediction and anomaly detection and prediction to thermal services, like if server is overheat, or there you will get one type of performance. If server is more loaded, then you will get one type of performance. So those type of information is very much required for taking proper decision. And after that, this power management also, device power also is critical role. Like when any device starts, it will consume more power. And as we know, because of all this system operation, so this type of inputs, when it comes, like when server starts, of course, we know that there will be power consumption more. So that type of inputs will not come as a regular input to this model. So that time, but if there is an abnormality, like suddenly, which is not supposed to happen, and server is running fine, suddenly it is consuming more power. So those type of inputs are required for this model. And again, I told this when we do proper load balancing in this data center, then different type of manpower requirement and this how it affects and regular operations that I'm just highlighting here. And here I'm giving just one focus of this security operations, which I am going to present in my coming presentation in detail. This is only one PPT how this SIEM, that is software, that is security information and event monitoring. So those type of event monitoring happens, and these events how they help for this taking but a better decision. So that kind of information is very much required. And then this alert mechanism, like when we have alert mechanism for any security, then because this alert has generated whether it is a known vulnerability or any new event has happened, those type of inputs also is required for this load balancing, so that it will automatically divert the user request or it will automatically stop the user request. Those type of operation are linked to load balancing. And then as we know, security is basically protect, detect and respond. So on this on next session we'll have in more details, and I'm just highlighting here how this load balancing also affects due to security events. And here I'm just showing some of the popular machine learning platforms which we all know, and that I will not discuss more on this because all these are very well known. That is Amazon, Analytics, SAS, Databricks, Microsoft Azure, also the data robots and rapid miner. These all are the platforms on which we can build our inputs, and to get a proper output and load balancing, we can take this platform as input and give data as an input model. So here basically what happens is like you have set of data, then you will have model, and it will do analytical analysis, and it will do the machine learning algorithms and take a better decision for this requirement. And prediction, do the predictions, and this after the prediction we have to validate properly, and this validation data whether it is properly required as per our requirement or any changes is required. So these are the normal concepts of our machine learning or any kind of algorithm when we build. But more focus what I have given here is the source of data, what is required for building a proper validation model for this load balancing. So that was the main focus of my today's presentation, and I hope I have conveyed the source of data and how this model will be integrated into this activities. Now this load balancing for image data hosting, and there I have already highlighted like internet data balancing we have to keep into mind. Then network data that is also we have to keep in mind. Then site load balancing, that is you have across the site many different sites are there for the same data. So there we have to go for site load balancing. Then data replication across the sites, that is data replication when we go for same data access from different sites. Then cloud data management, like when we go for data on a cloud environment, there also we have to see there also we need this information of this cloud data for input to this model. And this content delivery network. That is when we go for CDN kind of activities across the web, there also the CDN activities, basically it will be a front end data will be there, but when we go for live server access, and that time we have to give the server level information and authentication level information, which is generally in a CDN will have its a predefined data architecture. But whereas these data centers will have its individual device level operation. So how this device, when a user is landing to particular data center, how they has to be properly balanced to give a better response time. That is the model we are now discussing. Of course, this is some of these load balancing companies which I am highlighting here. That is F5, Citrix, IBM. Industry standard brands are there. They have popular products are there. Red Networks and Radware, A10, Barracuda. These all are just for overview. Like this, many industry standard companies are there who are dedicatedly working towards these activities, and they're also building new appliances for this type of activities for doing a proper load balancing in the data center. So just I'm giving some references also. Maybe we can discuss more on that, and that's all my presentation. Maybe some questions we can take up.
Thank you so much, sir. The
Yeah.
questions are welcome. Well, participants can post their doubts in the chat box so that we can discuss them right now. We still got some time.
Yeah.
Otherwise, you can always reach sir through his mail. It was given at the beginning of the session, I think. Any question, anyone?
Big problem. It is so. Okay.
Okay. I think we really understood well enough from the presentation. So we are really grateful to you, sir, for the lecture. As usual, your speech brought new insights from current research, and I think it will definitely motivate our participants to invest more in this particular field. Thank you again for this stimulating piece of knowledge.
Yeah, okay. If any specific questions we can discuss afterwards also.
Okay, sir. Thank you.
Thank you, ISRO scientist Subrat Kum. Thank you for accepting our invitation and give your valuable talk. Thank you very much.
Yeah, thank you, sir, for inviting for this occasion. Actually, it is a pleasure. Like more than almost 100 participants were there.
Yeah, this is approximately 200. 200 has shortlisted due to as per AICT norms.
Okay.
But there are so many participants are interested for this program.
Okay.
So next time we can skip for another program. Okay. However, all participants and speaker all are thankful for your interest and listening the talk. Thank you very much.
Okay, thank you,
then
sir.
thank you. Yeah, thank you. Thank you very much.
So we will move forward. It's time for the lunch break, ladies and gentlemen. Before moving further, I'll request all the participants to fill the attendance sheet positively. It is compulsory for all of you as your presence is being recorded. And don't forget to fill your FTP ID correctly, failing which you might be considered absent. Just mention the numeric part and not the alphabets or any special characters. Just mention the number. The link is already in the chat box. It was shared multiple times. So please check that before leaving the session. We will end this session here. We'll meet exactly at 2:30 in the afternoon. Another exciting session on the topic hands-on lab training for artificial intelligence using machine learning will be streaming then. And to our amusement, another guest speaker and an amazing personality is on his way to address us. So please join the respective link and be on time. See you all. Thank you.